How does a space shuttle pilot know exactly where to steer, even when flying upside down or at Mach 25, to land on a 300-foot wide runway from space? Stick around because the answer lies in one of the most overlooked but powerful instruments in the cockpit. In this issue of Spacecraft Guide, we are going to continue to teach you how to fly the space shuttle by focusing on the compass card and one of the components within it. Today we are going to be looking at the course deviation indicator, and when you click on the primary flight display, it takes you to the primary flight display webpage, and from there we're going to go down to the bottom here to this right here, which is the course deviation indicator, and this is the course deviation indicator needle. And when you click on it, it takes you to the course deviation indicator page. You see it labeled right here. Now what this is this is the display is a fly to indicator. So you want it just like the error needle, you want to fly to this. And you're for flying the vehicle to the extended runway centerline. So you're going to the end of the runway. The software processor also ensures that the course deviation indicator remains fly to even when the orbiter is heading away from the runway. So if even your orientation changes, like if you're upside down, this needle will actually point to the runway, and that's where you're going to have to turn the spacecraft to go intercept the center line of the runway. Why was magnetic north used instead of true north? Why was magnetic north needed to land safely back on Earth? Sign up to my Patreon page to find out for free. The course deviation indicator is driven to zero during entry. So we're trying to go to zero is lining up with this indicator right here. When the course deviation input is 0, the deviation bar is aligned with the end of the course pointer, this being the course pointer right here. So the pointer in the top half of the compass card, this being the compass card, and an increase in course deviation to the left. So if we deviate to the left, causes the bar to deflect to the right, so it will come this way. So this is actually opposite why they put it in, why we have it here in brackets. So a deviation to the right causes the bar to move to the left. So if the runway's over here, the center line, as you move away further and further this way, this indicator is going to move this way, telling you you have to move over. Now, that is all that we described on that. We're going to go into the schematics, and this is for our Patreon subscribers, not only the paying subscribers, but the free subscribers. And what are you waiting for? It's free. So all you have to do is go to my Patreon page for the SIVR Museum, and that link will be down below, and you can click on it. It'll be down here. And when you do click on schematic,